All right, so again, today we're going to be talking about slope and linear equations. Miss Warninger is sick today, so she's out. She's fully vaccinated, so I'm going with no. Thank you. Have a seat. All right, so the first thing that I want to just refresh your memory of is going to be what is slope. Slope being a constant rate of change. Now, the concept of slope is extremely important in mathematics, not just with algebra, but working all the way up through calculus. The foundations of calculus is working with slope. So the basic idea that we're going to go over is just on average, how much is something changing, whether positive or negative, over a span of time or distance or something of the sort. Now, a slope says it's the constant rate of change. So for all of these problems, once we find the slope, we can assume it will never change because it is constant. So if you were to think of driving a car and you start at one place and you end at another place, even though your speed is fluctuating, we can find your slope from point A to point B, meaning your average rate of change. So when I get in my car, I'm starting through a neighborhood. I go onto 101. I'm going around Dublin Lake. I'm going through Dublin into Peterborough. My speed fluctuates a lot. It can go as high as, the speed limit, of course, so 55, or as low as 10, 15 miles an hour, depending on what we have. But when we talk about the slope, we're talking about what is the average speed. So maybe on average, I drive 33 miles per hour. Now, I may have only hit that a couple of times, but obviously as my speed fluctuates, the fast ones cancel out with the low ones and we get the average. That's what we're talking about with slope. It's just the average. It's not very realistic on a moment-to-moment basis, but it is extremely helpful with predictions. So on average, if we're going this speed, where we end up, where did we come from, things like that. Now slope, the symbol for it, or the letter, is going to be the letter M. So whenever you see M working with linear equations, that's what our slope will be. Now, how do we find that M? How do we find that slope? So to do it in terms of Greek letters, triangle Y over triangle X, that triangle, it is a Greek symbol pronounced delta. So delta Y over delta X, that is the mathematical formula for slope. But you may know it as the change in Y divided by the change in X. So how far did we go over how much time went by? And then if you're the type that like a formula, hopefully you remember y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So these two formulas, one is a more intuitive way. It is quicker, and it will allow you to find the slope between 2 points relatively quickly. But if you don't like the bigger picture and you just like the steps and the directions, then the y sub 2 minus y sub 1 over x sub 2 minus x sub 1 will be your way. So the first one is going to be kind of the bigger picture. We can find slope really, really quickly. This one down here is actually plugging in points, subtracting them, and doing them. So the second one is easier to understand, but it takes longer to calculate. The first one's a little bit harder to understand, but easier to calculate. All right, so I'm going to overly complicate this question. So if I traveled 60 miles in 2 hours, how many miles per hour did I travel? So you might think about this, all right, so if you did 60 miles in 2 hours, then it must be 30 miles in 1 hour. And you'd be correct, that will be the answer. But to put it in context of what I'm saying with the change in y over the change in x, one moment. All right, so in terms of the change in y over the change in x, I would have my y values and my x values. Now, if I wanted to plot this situation, what would be happening is I'd be starting right here at 0, 0. So that means that 0 time has gone by, I've gone nowhere. I've traveled 0 distance. After 2 hours, I'm claiming that I've traveled 60 miles. So that means I would have a coordinate point right here at 260. So since I had a starting point and I had an ending point, I can then draw a line between these 2 points. That on average, this is the distance that I traveled. Now, obviously, like I said, that you could be going through different areas, whether it's the highway or a neighborhood, on ramps, off ramps, all that stuff. So you're obviously not going to be holding a consistent speed, but overall, we have an average. Now, by doing this, I can think of the intuitive way. So the change in y over the change in x. So if I were to think of it this way, I'm going from 0 distance to 60 miles. The change in my x values is going from 0 hours to 2 hours. So if I just think where I started, where I ended up, how long it took me to get there, I am getting the ratio of 60 over 2, or 30 miles per every hour. So this is how you can kind of do the math without using the formula. You just think, all right, so I went from 0 to 60, so that's a change in 60 miles. And I went from 0 to 2, so that's a change in 2 hours. So 60 over 2 is 30. If you wanted to use the formula of y sub 2 minus y sub 1 over x sub 2 minus x sub 1, then that would be 60 minus 0 over 2 minus 0, or 60 over 2, which would give us 30 as well. So you're free to think of the bigger picture and to go from one value to the other, which I think is going to be quicker. Or if you just want to acknowledge the 2 coordinate points, plug in your x sub 2, your y sub 2, your x sub 1, your y sub 1, and then you'd get it that way. You're free to do it either way. So in this example, my slope, or my average rate of change, would be 30 miles per every hour. All right, so if I gave these 2 problems and I just asked what is the slope between these 2 points, there's no longer any context to these points. However, we can still use both methods. So if you want to use the first method of thinking of their picture, think to yourself, how far did I have to travel to go from -2 to 3? That's going to be my numerator. How far would I have to travel to get from -1 to 3? That's my denominator. Those 2 as a ratio, as a fraction, would be your answer. If you don't like that, then set it up as x sub 1, y sub 1, x sub 2, y sub 2, and plug it into the slope formula. It will get the same result. I'm going to go ahead and pause the recording, give people a few moments to try to find the slope between these 2 points, and then I'll go over it both ways. I'll go over it with the formula, then also again seeing it as kind of the bigger picture of things. All right, so with number 1, I'll do it using the formula, and then we'll do a thing of the bigger picture, which, as I said, I think will be quicker. It's just whether or not it's easier for you. So if I want to use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1, just plug in the values after you've labeled them. So 3 minus a negative 2 over 3 minus a negative 1. So you can see how this can get a little complicated because you have to worry about your double negatives. But 3 minus a negative 2 is the same thing as 3 plus 2. And 3 minus a negative 1 is 3 plus 1. So I am getting 5/4 to be in the slope of the first problem. Now, to think of it as more of the bigger picture of how much are my y values changing, how much are my x values changing, if I start at negative 2 and I end at 3, would I have to increase or decrease? Well, I'd have to increase because I'm going from negative to positive. How much am I increasing by? Well, negative 2 to negative 1 to 0 to 1 to 2 to 3, that's a change in 5 units. So the change in my y value is 5. To go from negative 1 to 3, I'm going negative 1 to 0, 1, 2, 3. That's an increase of 4 units. So I'd have 4 as my denominator. So you don't have to do this math. If you ever took Algebra 1 Part 1 or Algebra Concepts, you were doing that math. Well, we're done with that. If you want to keep doing that math, you're free to do that, but there is a quicker way. Just you're at one point, you're moving to another, so how much did it increase or decrease by? For the other one. Again, I'll do the math out. I'll call this x sub 1, y sub 1, x sub 2, y sub 2. So I'm going to do negative 2 minus a negative 3 over negative 6 minus 8. So I'm getting negative 2 plus 3 over negative 14. So I'm getting 1 over negative 14 or negative 1/14. Think of it as the more intuitive way. If I were to go from negative 3 to negative 2, I'm getting closer to 0, so I'm increasing. I'm increasing by 1 value. So my numerator would be 1. To get from 8 to negative 6, I'm decreasing. Well, by how many units? I would have to decrease by 8, decrease by 6 more. That's a total of 14 units that's decreasing by. So then that's how I get the negative 14. So the question is, it works either way. Yes, I could label this x sub 2, y sub 2, x sub 1, y sub 1, and go backwards. Or looking at the bigger picture, to get from negative 2 to negative 3, I would be decreasing by 1. And to get from negative 6 all the way up to 8, I would have to increase by 14. And I'm still getting the negative 1/14. So it really doesn't matter at what point you start at. It's just how much is it changing by. So again, this is a little bit more of a complex way of looking at it, but the math is a little bit easier because you're only just adding or subtracting and then putting it as a fraction. Okay. So when it comes to writing the equation of a line, there's actually 3 different forms. The one we're going to focus on is slope-intercept form because that's the one that is used most often, and I would guess that you guys would be most familiar with it. So I figured it would be advantageous to use what you're more comfortable with versus what might seem a little more confusing. So we're going to be using slope-intercept form, which its form is y equals mx plus b. The other two forms, just in case you're curious, that we're not going to be using, the first is our standard form, and that is ax plus by equals c. This one is a pain in the butt because you don't know the slope when you look at it, and it has a lot of restrictions, like a has to be a positive number. It also can't be a decimal or a fraction. And then b and c can be either positive or negative, but they also can't be decimals or fractions. So just to write it in standard form, you'd have to make sure that you're not going against the restrictions, because otherwise it wouldn't technically be standard form. So that's why I'm not using standard form. And then there's one called point slope form. This is the easiest equation to write, the equation of the line, but it's really abstract. And that would be y minus y sub 1 equals mx minus x sub 1. So that is also an equation of a line. But again, these are two forms that we are not going to be using, but they do exist. We're going to stick with just slope-intercept form. Now with slope-intercept form, this m, we should now know it to be slope. This b value is the y-intercept, meaning wherever the graph crosses the y-axis, at whatever y value it is, that's what would go in place of b. The x and the y in this equation is in terms of a coordinate point. So if I want to find one of the missing values, most likely we've been given a coordinate point, and then we either know the y-intercept or we know the slope. So we're always going to know 3 out of 4 of the variables. It's plugging in what we know and solving for what we don't. Now, when we write the equation of a line as our final equation, this y and that x should still be there as a variable. It's the m and the b that we're going to replace as a number. So every single time when you write the equation of a line, it's going to be y equals a number x plus a number. So this x and that y is going to stay in our equation, because the purpose of an equation is that we can find any x value or any y value by following the pattern of the slope and starting where our y-intercept began. So we leave that as y and x. In fact, I'm going to write down 3 equations, and you're going to see that there's going to be a slope and a y-intercept to each of them. And there's also going to be the letter y and the letter x in all 3 of them as well. All right, so here are 3 different equations. Now, just looking at these 3 equations, I can start to understand what's going on. Now, if I said that these were 3 models that represent the speed and distance traveled by 3 different drivers, what would these numbers then mean? So if I look at this first one, I see that I have a slope of 35. So that means that its distance is traveling 35 miles for every hour that passes. I do not have a y-intercept. So I can assume that this y-intercept is 0. So there is some sort of starting location. This vehicle is going to start at that starting location, and then it's going to change its speed by 35 miles every hour that it's driving on average. So I'm going to go over to Desmos, and I'm going to type that and see what it looks like. You see, I need the y, I need the x. The reason why is that if I were to plug in 1/2 in for x, its y value would be right here. If I plugged in 1 for x, its y value would be right there. So there's an infinite number of points that could exist based off of what x value or what y value I want. So this represents the distance traveled by car number 1, the blue car, we'll call it. And so I can see that after 1 mile, it's traveled 35 miles. After 2, it would have traveled 70. So we can kind of see how its pattern is going. Now, what's happening with this car here? Well, according to the second car, it has an average rate of 30 miles per hour. So that means it's going slower. But that 20 means that it would have had a head start. So it's starting 20 miles ahead of the first car, but driving at a slower rate. So y equals 30x plus 20. And so when I look at this, I see that they're slowly converging. And at this point, they're gonna intersect. Well, what would be the importance of these lines then intersecting? What does 4, 140 mean? Well, we have the blue car that started at a spot and is going faster than the black car. The black car had a head start, but obviously the blue car is going to catch it at some point. And according to my graphs and by having these models, I know that after 4 hours and after 140 miles traveled, that the black car and the blue car will be at the same exact point. Now, this third car has a slope of 63, which means it's moving a lot faster than the other 2 cars, but it has a y-intercept of -25. Thank you. Wait, it does have that I'm sharing. Oh, up there you can see it? Gotcha. Thank you. All right, so with this one, I have a slope of 63, and the -25 means that I am starting 25 miles behind wherever this one started. And so this one started 25 miles ahead of the 63x minus 25, and this 30x plus 20 started 40 miles ahead of this one. But obviously it's going really fast, so it's going to catch up. So I'll do y equals 63x minus 25. And now what I have is this red car is intersecting these lines at 2 different points. Well, what do they represent? Well, the blue car is traveling along at 35 miles per hour. And after 89 hundredths of an hour, the red car is going to fly past that blue car. And then it won't be until hour 1.36, so about an hour and 20 minutes later, it's then going to pass the black car at about 61 miles down the road. So by having a slope, having a y-intercept, it allows me to model a situation on average to figure out where the cars end up and where they will be. In calculus, I go over this problem, which is called the mean value theorem, which says that if you know the average speed of a car, and this actually was used in a court case, that there was a cyclist, a motorcyclist that was driving on the highway and got a ticket in the mail saying that he was clocked at going 89 miles per hour, but he was never pulled over and he was never notified. All he received was a ticket in the mail and a date to go to court to fight it if he wanted to. So he wanted to fight it because no one ever told him that he got pulled over. He had traveled one day, got home, a couple days later, got a ticket in the mail. Well, the way they were able to prove it is that if his average speed was 89 miles per hour from one toll booth to the other, then there has to be at least one point that you did go 89 miles per hour, And even though he may have gone faster, he obviously went slower, but since his average speed held up from one toll booth to the other, they were able to write him a ticket for exactly 89 miles per hour or 20 some odd miles over the speed limit. Even though they never actually clocked him, it may not have been the fastest that he ever did, but because his average was faster than the speed limit, they were able to give him a ticket without ever catching him. So it's just kind of a unique way of using that math and using the concept of slope to uphold it in a courtroom. All right, so that is our slope-intercept form. In every equation, you will have the slope and you will have a y-intercept. And then you'll notice in our final answers, the x and the y will stay in its place. We only use that to find the missing values, which we'll do right now. Yeah, we will in a little bit. All right, so if I was given the information of finding the equation of a line with a slope of 4 and it's going through the point 1,3, what this problem has now given us is that we know the slope, we know the x value, we know the y value. The only thing we don't know is the b value, the y-intercept. So what I'm going to do is I'm going to write all the information I know and then solve for the missing variable. So using y equals mx plus b, I know that my y value is 3, my m value is 4, my x value is 1, and I do not know my b value. So this is just in an instantaneous moment in time. When x is 1 and y is 3, we're going to work backwards using that slope to figure out what should have the y-intercept been. And then from there, we can then write the equation. So 3 equals 4 plus b. Subtract 4. And I know that my b value is -1. So to write the equation of the line, I'm only going to use the slope and the y-intercept. I'm not going to use the x and the y value now because I want a general slope-intercept equation. I don't just want all the values thrown in there. So y equals 4x minus 1 is going to be the equation of the line whose slope is 4 and pass through the coordinate point of 1, 3. But then when I write the equation, I write it in terms of x and y so that I am free to plug in any value of x or y. All right, last two things we'll cover today are going to be parallel and perpendicular lines. So to use our geometry notation, I'm going to show that line AB is parallel to line CD. Now the symbol in between the line AB and the line CD, those two vertical lines, that is the mathematical symbol for something being parallel. To draw this situation, That means I have something like this going on. I put the little arrows in the middle to show that they are parallel, but I have line AB and line CD, and they're going along and they are parallel. Now, since they're going along at the same rate, as in they are both increasing at the same rate, both decreasing because they can never collide, then we can assume that parallel lines have the same slope. Now, why this would be important is that if I know the equation of one line, that means I know the slope of that line. If I know the slope of that line, I know the slope of every line that is parallel to it, because they would share the same slope. I also know that parallel lines have different y-intercepts. Because if they had the same y-intercept, that would mean that they would have to collide at some point. And the thing about parallel lines is they never touch because they always stay the same distance apart. So if they did have the same y-intercept and the same slope, they'd be the same line, and that's not parallel. So you kind of have a little bit of a self-check in here that if you have a parallel line, your other parallel line should have the same slope, but a different y-intercept. And so if I gave you an equation of a line of y equals 2x plus 5, and I wanted you to find the equation of the line that's parallel to the line through the coordinate point 1, 4. So you now have all the information you need to find the equation of the line that is parallel to y equals 2x plus 5. So we know that the slope of the new equation is going to be 2 because I'm taking it from the other equation. I know that the x value that I'm going to be plugging in is going to be 1. And I know that the y value I'm going to be plugging in is 4. So I know 3 out of the 4 variables. I know my m, my x, my y. What I don't know is my y-intercept or my b value. So I'm going to use my y equals mx plus b. And I'm going to plug in the 3 values that I know so that I can solve for the unknown value. 4 equals 2 times 1 plus b. What's nice about these problems is it's the same process every single time. So 4 equals 2 plus b, subtract 2, b equals 2. So the equation of the line that is parallel to y equals 2x plus 4 is y equals 2x plus 2. So I took the information they gave the problem, plug it into the equation, and whatever's left, which is the y-intercept in this case, we solve for it, and we now know that it had the same slope, and its different y-intercept is 2. And the last one are going to be perpendicular lines. AB is perpendicular to CD. That symbol in between, that looks like an upside down capital T, is the symbol of something being perpendicular. Much like the parallel symbol, it was just two parallel segments. This symbol here are two perpendicular segments. So perpendicular means that when they connect, they meet at a right angle. So a 90-degree angle. So if I wanted to draw this situation, I could have line AB and line CD. And then I'd put a little square in there because that would show that they are perpendicular. So the perpendicular slopes are always going to be opposite of the reciprocal of the other slope. So what makes something an opposite? It's when they have the same base number, but different signs. So for instance, the number 4 and -4 are considered opposites. So you have one that's positive, its opposite would be negative. If you were negative, its opposite would be positive. So if I gave you a slope and the slope was, say, 2, the opposite of that slope would be -2. If the slope was -1/4, its opposite would be +1/4. Now the reciprocal, a reciprocal of a fraction is when you flip it. So the numerator becomes the denominator becomes the numerator. So reciprocals are when we flip our fraction. So for example, if I had 4, its reciprocal would be 1/4. And if we had 1/4, its reciprocal would be 4. So in order to find a perpendicular slope, we have to do both of these. We have to take the opposite and we have to take the reciprocal. Find the equation of the line perpendicular to y equals 1/3 x plus 4 through the point 2, 4. with this right here, plus 4, yeah. So things that we know x is 2, y will be 4, and our slope has to be the opposite of the reciprocal of 1/3. So 1/3 was positive, so its opposite would be negative. And the reciprocal of 1/3, if we flip that fraction, would be 3/1, or just simply 3. So the perpendicular slope to the line y equals 1/3 x plus 4, its slope would be -3. So again, I have 3 out of 4 variables answered. So when I plug it into y equals mx plus b, I have 4 equals -3 times 2 plus b. And then when I go through to solve for b, 4 equals -6 plus b, add 6, add 6. My y-intercept is equal to 10. So the equation of the line that is perpendicular to 1/3 x plus 4 going through the point of 2, 4 is y equals -3x plus 10. Again, notice how there's an x and a y in my answer, and I've solved for the slope and the y-intercept.